On the back side of today's notes is the section on factoring by grouping. So on the first page we saw one method of factoring, and that's called factoring by GCF, or factoring by the greatest common factor. There is another method called factoring by grouping. On the top, if you read your handout, it says some polynomials do not have any common factors for all terms, so we cannot factor by GCF. One strategy we can use when this occurs is factoring by grouping. So again, we factor by grouping when not all the terms in our polynomial have a common factor. So you're asked to apply the distributive property to x plus 2 times x minus 4. So let's go ahead and do that together. You have x plus 2 times x minus 4. Applying the distributive property, just making sure that every single one of the terms are multiplied. X times x equals x squared. X times negative 4 equals negative 4x. We have 2 times x, which equals positive 2x, and 2 times negative 4, which equals negative 8. So now we have a polynomial, x squared minus 4x plus 2x minus 8. We cannot factor this new polynomial by GCF since there is no common factor for all of the terms. There is no number that we can factor out or no variable that we can factor out from all 4 terms in this polynomial. However, what we can do is look for factors that go into just each pair of terms rather than all 4 terms. So what that means is I can break this polynomial up into x squared minus 4x and positive 2x minus 8. So now I just kind of broke them up, and instead of looking for factors in all 4 of the terms, I'm going to look for factors that exist in the first 2 terms and factors that exist in the second 2 terms. So I'm actually going to rewrite this in different colors so it's a little easier to visually see what I'm doing. So again, the first 2 terms were x squared minus 4x. The second 2 terms were positive 2x minus 8. So what I'm going to do first is factor out the greatest common factor of the first 2 terms. So if I look at x squared minus 4x, in both of those terms what they have in common is the variable x. Both x squared and negative 4x have an x in common, so I'm going to factor out an x. So that's equivalent to saying x times x minus 4. Now what I'm going to do is look at the second 2 terms, or the second pair of the terms in my polynomial. So I'm going to look at 2x minus 8. And in those 2 terms, what I see they both have in common is a factor of 2. The greatest common factor of 2x minus 8 is 2, meaning that 2 is a factor of 2x and a negative 8. So if I factor out the positive 2, what I'm left with is 2x divided by 2 is x, negative 8 divided by 2 is negative 4. And hopefully what you see now is we kind of turn this problem into having just 2 terms. I have the term x times x minus 4, and I have the term 2 times x minus 4. And this kind of just turned into a greatest common factor problem, where both terms in this polynomial have an x minus 4 in common. So what I'm actually going to do is factor out the x minus 4 from both of the terms. So again, factor out the x minus 4. And if I factor out an x minus 4 from the first term, what I'm left with is x. And if I factor out an x minus 4 from the second term, I'm left with the positive 2. So now what I did was I took a polynomial that originally was not factorable by GCF. I grouped parts of the polynomial together So I grouped it by the first two terms here, and then the last two terms here. I factored out the greatest common factor of x squared minus 4x to get x times x minus 4. I also factored out a 2 from 2x minus 8 to get 2 times x minus 4. And then now in the two terms that I have here, they both have an x minus 4 in common, so I factored out an x minus 4 from the first term, and then I was left with x. I factored out an x minus 4 from the second term, and I was left with positive 2. So this is my final answer.